Okay, let us now discuss question number 7 from the practice sheet. Question number 7 says an electrician has to repair an electric fault on a pole of height 5 meter. Okay. So what we got from this question, from this particular line, is that there is an electrician who need to repair a pole and the height of the pole is 5 meters. He needs to reach a point 1.3 meter below the top of the pole. So what it says is, to repair the pole he do not require to reach the top, that is the 5 meter. He need to be at 1.3 meters below the top, okay, for the repair work, because if he reach the top, that is exactly at the top of the pole 5 meter, so he will not be able to repair the top. So to repair the top he need to move only 1.3 meter down from the top, okay. What should be the length of the ladder that he should use, which when inclined at an angle of 60 degrees to the horizontal would enable him to reach the required position, okay. So what it says is, we need to determine the length of the ladder that he should use to repair the pole, which makes an angle 60 degree when inclined with the pole, okay. And also how far from the foot of the pole should he place the foot of the ladder. So let us solve this question. Let us understand the diagram of this question. Question number 7. This says that there is a pole. So first let us draw a ground level, and let us mark a pole on this ground level like this. This is a pole. The length of pole, let us say AB is the pole, and the length of pole is 5 meters. So on this 5 meter, the electrician need to move not up to the height of point A. He need to move 1.3 meter below this point A. So how much from the ground he need to move? Let us say this is the point C, where till this point he need to move, which is 1.3 meters below the ground. And how much this length BC? This BC will be 5 minus 1.3. So how much is 5 minus 1.3? It is 3.7. So I will say the length of BC is 3.7 meters. So what does this BC means? This means that the electrician has to climb only up to this point, that is only up to 3.7 meters from the ground to repair this pole, okay, because he did not need to move to the point A for repairing. He just move here C point, which is 3.7 meter above the ground, and he can repair the pole. So now he is using a ladder. We need to determine what is the length of the ladder that should be used, such that if he inclined this ladder, if he inclined the ladder at an angle of 60 degrees, okay, the ladder which the electrician is using, DC is the ladder, this ladder should be inclined at an angle of 60 degrees. So we need to calculate the length of this ladder, okay, that is we need to calculate the length of DC. Now for this angle I can see BDC. This BDC is a right angled triangle because this is 90 degree, this is a pole which is vertical. So if this BDC is a right angled triangle, I can see this angle is given as 60 degrees. With respect to this angle, I can see BC acts as the perpendicular of the triangle and DC acts as the hypotenuse of this triangle. So think about a trigonometric ratio which relates perpendicular and hypotenuse. So we know the ratio is sin theta, which relates perpendicular and hypotenuse. Sin theta, theta is 60 degrees, so I can write sin 60 degree is equals to perpendicular. What is perpendicular? It is BC upon hypotenuse is DC. Sin 60 degrees root 3 by 2, which is equals to base. Base is, sorry, BC. BC is 3.7 upon DC. The length of DC is unknown. So the length of DC will become 3.7 into 2, that is 7.4 root 3 upon 3, okay, meters. Now you can solve this 7.4 root 3 upon 3 to determine the final value of this DC, okay. So what I have seen is that to calculate this ladder is basically the hypotenuse of my right angled triangle. This pole BC is basically the perpendicular of my right angled triangle, okay. So we have the length of DC, this is the length of DC, okay. Now next is, it says also how far from the foot of the pole. What is the foot of the pole? This is the foot of the pole, this B point. How far from the foot of the pole he should place the foot of the ladder. What is the foot of the ladder? This D point is the foot of the ladder. So I need to determine how far this D point is from this B point. It means I need to calculate this length. I need to calculate dB, okay, this is unknown. So how to calculate dB? I can see with respect to this angle, this BC is the perpendicular and this dB is the base. So which trigonometric ratio relates perpendicular and base? We know that is tan theta, that is tan 60 degree is equals to perpendicular. What is perpendicular? It is BC upon base is BD. So tan 60 degree is root 3 is equals to BC is 3.7 divided by BD. So the length of BD you will be getting is 3.7 root 3 divided by 3. This is the length of BD, okay. That is the distance of the foot of the ladder from the foot of the perpendicular, from the foot of the pole, okay. So in this manner you need to solve the 7th question. You can see again this is a very logical question. You need to visualize the diagram. Try to understand the relation between trigonometry and this right angle triangles and the practical diagrams of right angle of various things that are available in nature. For example, this pole. So this pole is considered as the perpendicular. This ladder is considered as the hypotenuse, okay. Now let us move further. We need to solve question number 8. Question number 8 says from a point P on the ground, okay, there is a point P on the ground. So we have understood this much, that there is a point P on the ground. So question number 8, let us first make a ground and let us mark a point P. So from the point P on the ground, the angle of elevation of the top of a 10-meter tall building, okay. There is a building which is in front of this point P and the angle of elevation of top of the building. Now what is angle of elevation of top of the building? It means if I am standing at this P point, I need to move my head 30 degree upwards to observe the top of the building. So this is, let us say, the building. AB is, let us say, the building. So this building is given as 10-meter tall, and what is the top of this building? This A point. So I need to observe this A point from this P point. So how much I need to move my head upwards? I need to move my head 30 degree upwards, okay. I am neglecting my height. I am just observing this tower, okay, and which is 10 meter in height, and I am neglecting my height. So from this point P I need to move 30 degree up to observe the top of this tower or building. Then it says a flag is hoisted at the top of the building and the angle of elevation of the top of the flag staff from point P is 45 degrees. So what it says is, when I observed this point A, what I see? I saw that there is a flag at this point A, at the top of the building. At the top of the building there is a flag, okay, and this flag is, let us say, this AC let us say AC is the flag, this is the flag. So when I saw at the top of the building, I saw a flag AC on this top. So what I did is I moved my head more, okay, I tilted my head more and I observed the top of this flag staff. This is the flag staff AC. So I observed the top of this flag staff and I saw that to observe this C point, which is the top of the flag staff, to observe this C point, I need to move my head 45 degrees upwards. Okay, to move my head, to observe the flag staff, top of the flag staff, I need to move my head 45 degrees. That is, from this 30 degree, I need to move 15 degree more upwards to observe this top. Okay. So what I understood is, there is a building, there is a point P, the top of the building is 30 degree upwards and the top of the flag is 45 degree up. Okay. So I need to calculate the length of the flag staff and the distance of the building from the point P. What we need to calculate is length of this flag staff, that is length of flag staff means I need to calculate AC, okay, and the distance of this point P from the building, this is the building and this is point P. So from building I need to calculate the distance of this point P, so I need to calculate BP. Okay, so these are the two unknown quantities. Now first let us observe the right angled triangles. There are two right angled triangles that I can observe is, one is triangle APB and another is triangle PCB. Okay, APB and PCB are the two right angled triangles that I can observe. So I need to calculate the length of PB. PB lies in both the triangles. Okay, I need to calculate the length of AC. AC lies in only triangle PCB. So let us try to solve this. First I can see is, if I observe the triangle APB, this 30 degree angle, with respect to this 30 degree angle, I know the length of AB. Okay, AB is what? It is the perpendicular with respect to this angle. And what is the base? This BP. BP is the base with respect to this angle. Do I need to calculate the base also? Yes, I need to calculate the length of BP. So what I can see is, if I observe only triangle APB, I can relate this angle with this perpendicular and this base. So what is the trigonometric ratio that relates perpendicular and base? It is tan theta. So tan theta is equals to, perpendicular is AB and base is BP. So tan theta is tan 30 degree, which is equals to AB is given as 10 divided by BP. So this is 1 upon root 3, which is equals to 10 upon BP, and the length of BP is equals to 10 root 3 meters. So this is the length of base of this triangle, or the distance of this point P from this point B. This is what I know. Okay. Now observe the bigger triangle PBC, okay, or PCB. In PCB, this 45 degree angle, with respect to this 45 degree angle, I can see this is the perpendicular. This BC acts as the perpendicular and this PB acts as the base. So with respect to this PCB triangle, I can see this is the perpendicular and this is the base with respect to this angle 45 degrees. So what I can see is, I can relate this angle with perpendicular and base. That is again tan theta, which is perpendicular is BC upon base is BP. Now tan theta, theta is 45 degree, so tan 45 is equals to BC. Do I know the length of BC? No. BC, or I can write BC as 10 plus AC. Okay, BC is 10 plus AC upon BP. We have calculated the length of BP as 10 root 3. So tan 45 is 1. So you will get 10 plus AC is equals to 10 root 3. So you will get AC is equals to 10 to the bracket root 3 minus 1 meters. This will be the length of AC. Now what is AC? AC is the flagstaff, the length of flagstaff. Okay. So AC we have got, and we have got BP also, which is the distance of this point from foot of the tower or foot of this building. Okay. So this is the solution for question number 8. We have two triangles here and we need to determine the relation between the two triangles. You need to think how to get this relation, which relation should be first applied. See, I cannot apply tan theta is equals to BC plus BP first. Why? Because if I apply this condition first, I do not know the length of BC. Okay, and even I do not know the length of PB. So how can I apply this condition? It will be impossible for me to apply this condition. So definitely first I need to observe that triangle which has at least two quantities, that is at least one angle and one side of the angle of the triangle. Then only I can apply the trigonometric ratio. Okay. So this is the solution for question number 8. Let us move to question number 9. Question number 9 says, the shadow of a tower standing on a level ground is found to be 40 meter longer when the sun's altitude is 30 degree. Okay. So first let us understand this line, the shadow of the tower standing on a level ground. Okay. So there is a tower which is standing on the level ground. Obviously the tower has to be vertical, it cannot be slanted. So question number 9, on a ground level there is a tower. Let us say this is a tower. Okay, or let us reduce its length. This AB is the tower in consideration. Okay, the shadow of this tower is found to be 40 meter long when the sun's altitude is 30 degree. Okay, 40 meter longer when the sun's altitude is 30 degree than when it is 60 degree. So what it says is that there is a difference in the shadow when the altitude of the sun changes. It's obvious, you know this, because at the 12 noon you will find your shadow is smallest, and in the evening at 6 in the evening you will find your shadow is the longest shadow. Why? Because the altitude of sun is getting changed. If sun is, let us say, lying here, if sun is here, so the shadow of this tower will be like this. Okay, the shadow of the tower will be like this if sun is at this position, and if sun is here, then the shadow of this tower will be like this. Okay, so this AC and this is AD. So what I can see is when the sun move up, the shadow will reduce. When the sun move down, the shadow will increase. Okay, the length of shadow will increase. Now, why the length of shadow is increasing? It's because sun is moving down. Okay, if this is the first position, you can see the shadow is only BD. The length is very small, but one thing is very, very large. Which thing? The angle of elevation. Okay, the angle of elevation formed from this D point. If I want to observe the sun, I need to move this much. I need to move my head this much angle, which is a big angle. And if I am standing at this C point and the sun is here, so I need to move my head only this much. Okay, this angle is bigger angle, this angle is smaller angle. So what it says is the shadow of the tower standing on the level ground is found to be 40 meter longer when the sun's altitude is 30 degree. Okay, so obviously I can see when the sun's altitude is less, the shadow will be large. When the sun's altitude is large, the shadow will be small. So from this point I can see the shadow is like this. This BC is the shadow, which is the longer shadow. BC is longer in length. So I can definitely say that this BC represents 30 degree angle. Okay, 30 degree altitude of sun. It means 30 degree altitude of sun means if I am standing at this C point, I need to move my head 30 degree up like this, okay, like this to observe sun, okay. And if I am standing at this D point, I need to move my head like this to observe sun. So obviously BD is a small shadow. Why this is a small shadow? Because sun's altitude is large. Sun jitna upar hoga, shadow utna chota hoga. So definitely this angle is 60 degrees. This is what we have. It says that the shadow has a difference of 40 meters. So which is the longer shadow? Obviously BC is the longer shadow. So the length BC and BD, the difference between the two length is 40 meters. Okay, the difference between the two length of the different positions of sun, the altitude of sun, we have the difference is 40 meters, that is this length is 40 meters, this DC. Okay, what we need to calculate is find the height of the tower. So we just need to calculate the height of the tower. What is the height of the tower? AB is known as the height of the tower, which is unknown. So now let us try to solve this question. We can assume that let the height of AB is h, okay, and BD, this length BD is, let us say, x. If I observe triangle ABD, if I observe this angle of this triangle ABD, this 60 degree angle, this h is the perpendicular with respect to this angle and this x is the base with respect to this angle. Why? Because this angle is 90 degree. Okay, this is a right angled triangle. So this is the perpendicular and this is the base. So what I can write is a relation between perpendicular and base, that is tan 60 degrees is equals to perpendicular upon base in the first triangle. Then what about in the second triangle? In the second triangle is in triangle ABC. ABC is the second triangle. In the second triangle, this is the angle. With respect to this angle, this is again the perpendicular, and with respect to this angle, this BC is the base. So here I can write tan of 30 degree is equals to perpendicular upon base. Now what is base? BC. BC is x plus 40. This is what I can write. BC is equal to x plus 40. Okay. Now from this tan 60 degree is root 3. It is equals to h upon x. So what is the value of x? X is equals to h upon root 3. Can I write x in terms of h? Yes, I can write this. Second, here this is tan 30 degree. So tan 30 degree is 1 upon root 3 is equals to h upon x plus 40. So I can write it as x plus 40 is equals to h root 3. Okay, in place of I have just cross multiplied. Now you can see we have two variables x and h. So just by solving these two equations, I can determine the value of x and the value of h. Okay, but my task is only to determine the value of h. So what I can do is, this is x, which is h upon root 3. So from here I can substitute the value of x in this equation. So in place of x, I can write h upon root 3 plus 40, which is equal to h root 3. Now multiply the equation by root 3, complete equation by root 3, you will get h plus 40 root 3 is equals to, this is 3 into h root 3 is 3h. So this will give you 2h is equals to 40 root 3, which implies h is equals to 20 root 3 meters, which is the height of the tower. Okay, which is the height of the tower. Now what is the complexity in this question? The complexity is that we have two unknowns, this is h and this is x. I need to determine the value of h only, but I can determine the value of x also. It do not matter, because without determining the value of x, you will not be able to determine the value of h. So in first triangle ABD, I have applied tan 60 degree and I got a relation between h and x. In the second triangle, bigger triangle, I have applied tan 30 degree and again I got a relation between h and x. Now why I am getting a relations between h and x? Because h and x are two unknowns. So if somehow I get two different equations, then I will be able to determine the value of h as well as x. Okay, I need to get two equations to determine two unknowns or two variables. Okay, that is what we have learned in the linear equation chapter. So this is the solution for question number 9. You can see this question is again a very interesting question. Okay, so first you can note this, then we will continue.